All right, so make sure your cases are charged. You will need them. If you haven't already done that, there is charges upstairs in the GP building. All right, so we're going to look at the next part of bivariate data, which is on transforming data or transformations of data. So generally speaking, when we're looking at bivariate, remember, what kind of graph is this, guys? Tell me. What are the two letters? This is the X, and that's the Y. Yeah, you got two axes, two variables, hence why it's called bivariate. And generally, you'll have dots, yeah, in your graph. Okay, but what happens is sometimes when you're working with data, not all graphs are going to be linear. Okay, some variables might include something that's non-linear. Okay, and what that might actually, can anyone tell me what does a non-linear graph look like? Anyone know what's non-linear? Obviously, non-linear means not straight. So what kind of form, or what kind of data might, or what could your data look like if it's not straight? Say it again. Everywhere. It could be like all over the shop, yeah, like that. What else? What else? Tell me more. I'm looking for one specific type of data that is non-linear. Anyone know? Oh, what'd you say, Natasha? Curved. Good. And this is what we're working with, okay? Sometimes data might look like this. It could curve downwards like that. Okay? Not necessarily straight. Okay? And so what happens is, if you're trying to put a linear regression line through it, for example, like that, is the line going to be very accurate if you're trying to make a prediction? Probably not. Okay? Because the data doesn't go in a straight line, it curves like that. So the idea behind transforming data is you want to try and change some of the variables so that so what happens is what you want to try and do is maybe you might want to stretch some of the data. So instead of looking like this, it might end up becoming like this. Okay, you're transforming maybe the X variable, so you're making the X variables longer so that the data ends up becoming straight. Okay, so what I've done is I've moved the data that way. Or you might want to transform it so that it becomes so that the Y variables are a bit longer. So then that might look like maybe like this. So instead of moving it this way, you might move the data upwards. So you're doing a transformation on the Y variables, okay? But the idea is you want to make it straight so that you can actually make some sort of linear formula, and then you can make some predictions of it. Yeah, that's the idea behind transformation. Okay, so it's transforming the EV or the X variable or the Y variables. Okay, whether you're stretching it or making it shorter. Now, there's three types of transformations that we're going to learn about. Looking at squared or quadratic, you might see it as quadratic. We're looking at logarithmic or log, and then we're looking at reciprocal transformations. There's three things you can do. You can square your variables, you can log your variables, or you can do a reciprocal transformation on your variables, okay? And these are the different transformations here that you can use as well. It's on the table form. So when we're looking at squared transformations, if you're going to square the EV, what's happening here is you're squaring all of the X variables. If you're going to square the RV, then you're going to square all of the Y variables. So it's actually multiplying the variable by itself. So it makes the numbers bigger that way, or it could be that way. If you're doing a log transformation, same thing. Okay, it's going to change the variables. It might make the variables shrink, or it might make them longer, depending on what you're doing. So that's for your logs. And same with your reciprocal. So reciprocal is basically just 1 divided by whatever your X variable is, or 1 divided by whatever your Y variable is. Okay, those are the different transformations that we're going to look at. For today, we're just going to focus on squared though. So just squaring our EV and RV variables. All right. So how do you do that on your calculator? So looking at this, it's pretty straightforward. Everyone knows how to do this part. You all know how to put data in your calculator. It's not hard. Make sure, again, you've labeled your columns, whatever they might be. Okay, pretty straightforward. So in order to square them, and we'll go through it together, what happens is you go to another column, okay, and in here, you can call it whatever you want to call it, but in this line, or this row here, is where you can transform your data. Okay, so here, you transform it, you write down what you want to do. In this case, we're squaring it, so I'll show you how to do that shortly. And then what it does is it squares all of your variables. So for example, if your height, if your time was originally 2, if you squared it, what's 2 squared? 4. Okay. If your time was originally 4, if you squared it, it becomes 16. So on and so forth. Okay. And it'll be the same as well. If you wanted to square height, then it'll be whatever it is. Okay. But let's go through it on the calculator. All right. So let's get your calculators out. I want you to put this data in your calculator. You've got 2 columns, time and height. We're going to put it in a calculator. Yes. Cool. I don't know what you want to do, man. I don't have one with me. Yes. After this. Hey, let me do this. All right. Get your calculators out. Let's put this data in. Let's go. All right. So you've got it in there. You've got your variables. Double check that you've got them all right. Okay. So now, if I want to do, actually, before I even put it in a calculator, I do my transformations. Can anyone guess? Actually, let's read the context. So this person is jumping from a cliff, not killing himself. Yeah, he's a base jumper. And so he's jumped off a cliff, and it's recorded the height of wherever he is in terms of where he's jumped off over a period of 10 seconds. All right. 0 seconds, that's the height. At 2 seconds, he's gone down 20 meters. 4 seconds, he's gone down however that much is. And it's not the same amount each time. Okay, it's not linear. Okay, so if I was to graph this, what do you guys think this would look like if you were to graph it? Anyone know? Anyone want to take a guess? Related to what Natasha said before. Curved. It's going to be curved. Which way though? Curving upwards or curving downwards? He's jumping off a cliff, so down. Curving down. So if I was to put this in a graph, notice how the graph is not straight. Okay? And remember, I said the idea behind why we're doing a transformation is we want to make sure we can draw a straight line through this. And if you use a straight line right now, it wouldn't be a very accurate prediction. So we want to make this more of a straight line. Okay, so how do we do that? We've done that. What we need to do here is we need to apply a squared transformation on time. Okay, so how do we do that? Okay, let's do it. On our CAS, let's go back to this menu. How do I apply a squared transformation on time? So time is my EV here. So on my top column, I'm going to call this time, time squared. I'll just go time SQ. Where's Q here? There. Okay, and then press enter. So here I'm going to apply my transformation. Over here, okay, is where you do your transforming part. So here you need to press the equals sign or the equals button, and it does this. It's on the left side under control. Okay, and then you need to literally write what do you want to square? You want to square time. So type in time, TIME. If you've done it correctly, this should turn bold, and you want to square it. So to the power of 2, or you can do x squared there. So to the power of 2. And what that does is you might get, if you get a little menu that says what reference, do variable reference. Some of the calculators might do that. All right, but that's what our values are now for time squared. Okay, so I've transformed time. So what I've done is I've tried to stretch my x variables here so they're a little bit bigger. Now, if I go back here, go back here, this is curved. So if I was to now transform it and change this to time squared, okay, it makes the line now straight. Okay, so it's linear now. So from there, I can now actually make a proper prediction on what's going to happen and make a formula. So I've done that. And now what we need to do is we need to write down the equation, okay, for this of the least squares regression line with time squared. So keep that in mind. We've squared time. All right, so now we need to write down the equation for it. Remember the equation normally looked like this. Y equals A plus BX. Okay, so my equation is now going to be this. So if you want to do your equation, you can do it from here. Otherwise, normally I get you guys to do it here. So we're going to go menu, statistics, stat calc, A plus BX. Okay. Here, okay, remember, what did we transform? What are you going to put in X? Instead of the normal time, remember I squared it. So I'm going to put time squared on my X variable. And on Y, it's the height. Okay. So there are my variables here. Now remember, on your calculator, on your formula, you're only changing A and B. Okay, so it's going to be y equals, what is A, plus whatever B is. And then, B, and then x squared. Remember, you've squared that x variable. Okay, so keep that in mind. All right, so looking at my calculator, y, actually, what does it say in terms of sig figs? Oops. Sorry. Does it tell us to do... Nope, no significant figures. Okay, actually it does say 4. Okay, 4 sig figs, so let's do that. All right. So 4 significant figures for this. My A, I can see is 1559.8. 4 important numbers. So it's going to be 1... Actually, let me change color for this, sorry. 1, 5, okay? Remember, 4 important numbers. So that 5, or that 8 will transform the 9, which transforms the 5, so it should be 1560 for the A. Now the B, okay, see how it's negative 4.9007. So this becomes minus 4 point, look at the 4 important numbers, that 7 will affect that 1. So 901. X squared. Okay, there's my formula. Remember, make sure you change whatever it is you transformed. So if you transformed y squared, change that to y squared. So there's my formula so far. Now, a couple more things I need to change is I should change my y variable and my x variable to whatever they are in this question. So my y variable, remember, is height, and my x variable is time. So let's just change that as well. Really important that you do. So it's going to be height is equal to 1560 minus 4.901 multiplied by time squared. Okay, so that's how you do the proper formula in year 12. This is what they expect you to do. Don't just leave your formula as this. Okay, that's only a 1 mark. Okay, if you do it this way, that's 2 marks. Okay, so there's my formula. Now, using this equation, okay, we need to predict the base jumper's height in meters after 7 seconds of the jump. Round your answer to 4 sig figs. Okay, so using our formula, which is this, we need to figure out what is the height of the base jumper after 7 seconds. Now, we can check this as well, that our answer should be, if it's 7 seconds, it should be somewhere between these values. Okay, so between 1383 and 1246. Okay, so our formula was this, yeah? Oops, y equals, or height equals 1560 minus 4.901 times, okay, look at the question, 7 seconds. So 7 squared. Okay, remember, we've squared that x variable. So what I like to do is on my CAS, I actually like using the solve function here because it does get a bit tricky later on. So let's use our solve function. SOLVE bracket. Okay, look at the formula right there. So it's going to be, we'll just go back to the y equals 1560 minus 4.901 times 7 squared. Okay, then comma y, because we're looking for the y variable. Okay, and there's our answer, 1319.851. And you can double check. Okay, it was 1319. Oops. Actually, it did say 4 sig figs, so let's change this to 1320. Actually, I'll put the full answer. 19.85, which equals 1320 meters. And remember, you could check your answer to make sure that you're in the right. And our answer should be between these two. So 1383 to 1246 and 1324 is in between that. So we did it right. Okay, so use your solve function for the predictions. It helps out a lot. Okay, so that's your transformations for your squared transformations on Eevee. Let's do the same on our RV. Okay, so let's skip this example. We're just going to go to the next one here. A squared transformation on RV. Okay, so this time, instead of transforming EV, which we've already done, so that's what that looks like for an EV transformation. Remember, originally it looked like this. Just it's curved, yeah? The idea is you want to make sure it's a straight line. So go back to this. Let's get rid of all this because we don't need it anymore. Except for the data. Don't get rid of the data. Oops. Okay, get rid of this. So I've got time squared already. Now let's square our height. So on this column, let's call this height squared. G, H, T, S, Q. Yeah, let's just go with that, squared. Okay, this is now going to be squaring the height, so squaring the RV. In this column here, sorry, this row is where you put in whatever the transformation is. So if you type it up, IGHT, the variable that you want to transform, if you've typed it correctly, it should go bold. And remember, look at the question. It says we're now trying to transform height. So transformation on height. So it's height squared. All right, so height to the power of 2, or you can just write x squared there. Okay, and again, if it gives you a little menu where it says what reference, you're going to go variable reference to get all these numbers. So what it's essentially done is 1560 squared is that. 1540 squared is that. Okay, you've squared your variables. So remember on our data, it looks like this. So if I square my height, what will have happened? Okay, as you can see, it's not as good as time squared, but it's what the question is asking us to do. Okay, so there is my graph now. It's changed. Let's go back to this because we now need to write down the formula. So remember the formula is y equals a plus bx. And what you're changing is a and b. So it's going to be y equals whatever a is plus whatever b is x. Now remember, what did we square here, Ryan? Instead of x, we squared y. So it should be y squared is equal to whatever the values are. Okay, so let's find out what that is. If you forgot how to do your formula, finding your formula here, menu, statistics, stat calc, a plus bx, so number 4. Remember, x we didn't transform this time, so it just stays as time. But we did transform y, so we're going to call it height squared. Okay, so be mindful of what you have transformed when you do these questions. Okay? All right, so it's really small, eh? There it is. Okay, so a is going to be 2591299. Now, it does say to do nearest whole number. Okay, so we're going to round this to the nearest whole number. So that should be 2591300. Okay, for our A. And then our B, nearest whole number again. So it's minus 131206. Okay, and there it is. Now, you can't just leave it there, yeah? You've got to make sure you change your EV and RV variables. So be mindful of what you transform. So this should be height squared is equal to 2591300. Take away 131206 times our time. Remember, this time we're not squaring time, we're just squaring height. So that's my full formula and what it should look like on my SAC, on my exam. All right, question B, we're going to make another prediction again. Okay, the prediction here is now, make a prediction on the height after 5 seconds. Okay, so if it's after 5 seconds, it should be somewhere between these values, 1482 and 1383. Okay, so let's make a prediction. So height, squared is equal to 2591300. Take away 131206. Sorry, that's not a decimal. Multiply by time, which is, in this case, 5 seconds. Okay, so let's use our calculator for it. solve function again. So SOL, oops, VE. Okay, so it's going to be height squared. We'll just go y to the power of 2 is equal to 2,591,300. Take away 131,206 times 5, comma. Remember, we're looking for y here this time. Okay. There you go. Okay, so if you get that, just press Control Enter. But there's our value. So it's either of these. Obviously, it's the positive one, yeah? So 1391. We'll round it to, does it say to round? I think it does. Whole number, okay? So it should be height is equal to 1391. I'll just leave it as that. 1391. Oh, where did it all go? Oh, yeah, sorry. Equal to 1391. Okay, and you can check your answer. If it's 5, it should fall between these two. Okay, and these two, which it does. Cool. All right, any questions with that? So the transformations aren't necessarily that hard. It's probably just getting your head around rewriting the formula and making sure, okay, that you're using the correct variables. Okay, so in year 12, remember, make sure you write your formula like this. Don't leave it. Okay, don't just leave it as this. And be mindful of what it is you're transforming. Generally speaking, the questions will tell you what to transform. In year 12, however, you know how there's like 6 things you can transform here? Sometimes you'll have to figure out which one is the best. Okay, but there's a way to figure that out. We won't talk about that today. But for now, that's